Good morning, students. So in our last class from the exercise 6.5 up to question number 3 we have done. In our last class the question number 3, the last question 8 we have done. So today we have to continue this exercise and we start from question number 4. And now here if you see the question number 4 is given like in this way: prove that the following functions do not have maxima or minima. That means if this type of questions are given like fx equal to e to the power x, gx equal to log x, or hx equal to x cube plus x square plus x plus 1, if this type of questions are given to us, here the functions do not have maxima or minima, we have to prove. So now here, how can we prove this type of questions? We have to discuss here. Is it clear? Okay, let's start now. So now here, the first one, if you see the first one here, the first question is given fx equals to e to the power x. Here the first question is fx equal to e to the power x. Now the procedure is same. Whatever we have done for the earlier questions, the same process we have to apply. For that reason, first of all we have to differentiate here. If you differentiate this one with respect to x, ddx of fx we know f dash of x, and ddx of e to the power x formula we know which one is e to the power x, is not it? So here we write e to the power x, and after that the second step is what? We write f dash of x equals to 0. So that's why here we write f dash of x equals to 0, and in place of f dash of x we write e to the power x. So e to the power x equal to 0 here we write. So now one thing you see here, e to the power x equal to 0. So why we write f dash of x equals to 0? Because from here we have to find out the critical points to find out the maxima or minima. So in this case, e to the power x equal to 0. E to the power x equal to 0 means the exponential function. Exponential function we can't write equals to 0, because in place of x, if you put any value, suppose if we put x equal to 1, e to the power 1, e to the power 1 is not equal to 0. If we write suppose x equal to minus 5, then e to the power minus 5 means we can write 1 by e to the power 5. So 1 by e to the power 5 is not equal to 0, is not it? So that means here e to the power x equal to 0, this condition is actually not possible. Exponential function is not equal with 0. So only for that reason here we can't get here maxima or minima. So here the reason is already written here if you see, but the exponential function can never assume 0. Reason all of you know why not equal to 0. For any value of x, it may be positive value or negative value. So that's why here written, you see this one. Therefore, there does not exist C belongs to R. C belongs to R means C is any constant number here. Is it clear? C is any constant number here, and which one is a real number. So that means when we get this type of exponential function e to the power x equal to 0, from here we can't find out the value of x. So that's why here we write C belongs to R here, such that f dash of C equals to 0. F dash of C means here when we find out the critical points. Only for that reason here we write there does not exist C belongs to R. Is it clear? The main concept is what here? Exponential function is not equal to 0. But according to our procedure, we get e to the power x equal to 0. Only the reason is this one here. We can't find out here maxima or minima. So finally here we write hence. What we write here? Hence function f does not have maxima or minima. Reason behind, we can't find out here the critical points. Is it clear? Okay. After completing the first one, if you see the second question here, the second question is given here gx equal to log x. The second question is what? Gx equal to log x. Now this time this one is a logarithmic function. So the procedure is same. We have to differentiate this one. So g dash of x. So if you differentiate this one, g dash of x we get, and we know the formula ddx of log x is what? 1 by x. So ddx of log x is 1 by x, we write 1 by x. And after that, now the procedure is what? We write g dash of x equals to 0. So here, that's why we write here, after differentiating, we write g dash of x equal to 0. And in place of g dash of x, we write whatever we find out, 1 by x. This one we write here. So in place of g dash of x, we write 1 by x equals to 0. Is it clear? So now here, from here, we have to find out the critical point. To find out the critical point, if we reverse this one, 1 by x, that means we can write here x by 1. That means here also we have to reverse this result and we have to write 1 by 0. 1 by 0 means what? Undefined. So that means here the critical point is undefined. Is it clear? Or if you directly cross multiply this x, 1 equal to 0, it is not possible. Isn't it? So here the critical point is undefined. Only for that reason, here we can't find out maximum or minimum. All of you understood this one? I repeat this one. Gx means log x. So if you differentiate this one, g dash of x equal to d dx of log x is 1 by x. Isn't it? And now g dash of x equal to 0 we write, and in place of g dash we write 1 by x. 1 by x equals to 0. So if we find out the critical point from here, x equal to how much we get? Undefined. Or if you cross multiply this x, 1 equal to 0, which is not possible. Only for that reason here we can't find out maxima or minima. So that's why here we write, since log x is defined for a positive number x, so that means one more thing we know, log x is always defined for positive number, isn't it? So that's why this g dash of x value is must be greater than 0 for any value, isn't it? Therefore there does not exist c belongs to R such that g dash of c equals to 0. C belongs to R means c is a constant number. So here already we find out x is not a real number, that means it is undefined. So that's why c belongs to R we write. We can't find out here a real number. So that's why c belongs to R such that g dash of c equals to 0. So finally we write down the conclusion. Hence function g does not have maxima or minima. Is it clear? So for that reason here we can find out, in case of logarithmic function, we can, especially in this question gx equal to log x, we can't find out maxima or minima. Is it clear? Okay. So in question number 4, one more question is there, and which one is given here? You see, given that hx equal to here given x cube plus x square plus x plus 1. The third one is this one. So this one is an algebraic function. So what you have to do, the process is same, we have to differentiate this one. So h dash of x equal to, here we write, and d dx of x cube means we write 3x square, isn't it? As well as d dx of x square means what? Twice x, and d dx of x is 1, and d dx of constant term 0. Ultimately the answer we get here 3x square plus twice x plus 1. Is it clear? Okay. Now here after that we write h dash of x equal to 0. H dash of x equal to 0 according to our procedure we write, and in place of h dash of x now we have to put this differentiation part. So this one we write here 3x square plus twice x plus 1 equals to 0. Is it clear? And now from here we have to find out the critical point. And when we find out the critical point here, x equal to minus b plus minus root over b square minus 4ac divided by twice a. But quadratic formula we applying here, and from here what we get, minus 2 plus minus root over minus 8 by 6. Root over minus 8. That means what? This one is an imaginary number. So that's why here we write x equals to imaginary number. X equals to imaginary number we get here. That means from here what we can say, there is no real number. So when we find out the critical points, always we find out the real numbers, is not it? But here when we solve this one, there is no real number. Here we get imaginary number. Only for that reason here we can't find out maxima or minima, is not it? So that's why here the conclusion we have to write here. You see this one, and finally we write here, therefore there does not exist c belongs to R. C means a real number, which one constant we consider here such that h dash of c equal to 0. Because here what we get? We get an imaginary number. Only for that reason here h dash of c equals to 0 is not possible. That's why here written, therefore there does not exist c belongs to R such that. And finally our conclusion is what? Hence function h does not have maxima or minima, because of here we get imaginary number. Is it clear? I hope all of you understood these three questions. Very simple question here. So in our next class, we have to continue this exercise and we have to find out that question number 5, which one is the absolute maxima and absolute minima we have to find out. So I hope all of you understood these three. So you have to copy these three questions properly, and we continue this exercise in our next class. We have to start the question number 5. Is it clear? Okay. Thank you.